Alright, here we go. Go Component Lab. Today we have a project scheduled. Let me pull it up. Probably 2 hours. Welcome back. Make any progress? So we're coming back to our RPC manager that we started in Go a little while ago. And we kind of left off creating these export functions to do some reflection, so you could actually take objects with methods or functions and export them as RPC, and so you can write them more like functions or methods as opposed to the handler API. And now the actual object manager is something that we can mount, and instead of exporting objects directly, we would just register them. This would then keep them, keep a reference to them in the object manager, and make them generate an ID and give them a unique path that you could address them at. You'd also get back a manage object wrapper that would give you that path, a reference to the value that you passed in, as well as dispose that would actually clean them up from the object manager. I'm not sure, the best way this will be used, but this is one approach. So we'll see how far that goes, and we should be able to register objects, and then hopefully we can register callbacks. And see if we can build a little callback example. We should be able to get that done. And more. So let's do it. What did you get stuck on? It should be in their API, what'd they say? Yeah, I can see you're trying a couple of ways here. Well, yeah, this will probably do that if it represents a bunch of items. you probably, when you create it, it's going to give you a key. Like I think, let's see, Firebase. One of these is going to give you back an object that has an ID, and then you'd probably be able to get a reference to it by doing something like ref items slash and then the ID. So you're close. I'd keep working at that. Oh, I'm sure. From that location, you need to get a reference to that particular item. So when you add an item, maybe that's what I wanted. To define path. Add to a list every time you push your database generates a unique key. So it should give you let's see, users. Set. So I guess it's doing a key. Or is there a push? It needs to give you back what this ID is. Getting you a key. Alright, so when you post, yeah, so in your code you would do before you do set, you say push, that's creating a new item. You want to set that to a variable. I wish I could just so this represents the item. Then you can do item set, but first, now you have item. You can get a what was it? The item key, right? So once you have the item key, then you can get a reference to it. Let's see, what were you? Something like this. So items plus, you know, your item key, right? And that'll give you the item.
You know what the water heater is?
In the garage.
It's in the garage?
Item remove. Firebase items, that's your reference to all your items. So if you did remove on that, it would remove all your items. So you gotta think in terms of keys and lookups and stuff like that. So that's kind of, hopefully that's helpful. I mean, you'll have to figure out how to pass the data around and keep a local reference of the key somehow. Usually if you look up the items, then you'll, you know, get the keys with them as well. So just read the docs. This concept of creating objects that reference a path. And so all of these reference a particular path. set will replace it, remove will remove the item at that path. When you say push, it's creating a new path. You have to find out what that path is, so then you can do stuff like remove it. Oops, I was actually doing that. Oh, a Google one. I wonder which one I should use. Their UUID package is in development and is not stable. That's crazy. I'm pretty sure I have this now. So we'll use UUIDs here for objects. I'll just keep that around. What's this? Bytes? A string. Can't see the keyboard. What is P? So it's gonna have a mount path, which normally we would know, but we'll mount it this way. That's pretty straightforward. Let's see. So create a path. Yeah. So I mean whatever remove is the key name. Yeah. You need to get the text of that. So I don't know what element your remove item is. Maybe it's an input box. But you would need to, I think it's, if it's an input, it's just remove item would be, I'm assuming, an input box. So, I mean, DOM input, text input. What do we have here? Value. So you'd want get element by ID, remove item dot value, because it's going to return a input text object. Value will be the text in the input box. But yeah, that should do it. Uh-oh. String, what's returning an error? Does this return an error? God damn it. Oh, that must be what must is doing. Right, because normally it would return an error. I guess I don't even need to. But we need to register it now. So that is really just saying values path. Okay, so we would need to. Maybe we don't need the managed object. We just need the value. We'll try with the value and see where that takes us. Crazy route. Hold on. Handler. Wait, what? Too many arguments. Oh, handle is what I wanted. So we started an object manager before, and that basically, last time all we did was do some reflection to convert, a function or a set of methods on an object, and make them, basically wrap them to be to implement our handler API, which is a very specific API, right? It's like a function that takes a responder and a call. So those functions, those export functions, let us now export certain functions or objects. And so we can say handle at this path, this function or this object and its methods. But this kind of then is going to take a step after that, so that we mount this object manager at a path, and then we can just give it any object, and then it will keep a reference to it, which we can always dispose. It gives us back a managed object interface that wraps it. So we dispose it, it'll remove it from this object manager, but it'll also give us a path. So it generates a UUID, a subpath of wherever we mounted it, and so then we can call that object. So it's just really just wrapping up some of this export stuff, you know, automates managing them. What are you doing today? Why are you in my channel? Oh, it's good to see y'all. Paste it. Let's see your code. And then at the same time, I'm also helping Crimson here make a little CRUD app with Firebase. So these are elements. These you probably, okay. RPC items. Value, this is going to be the key. So yeah, assuming remove item has some value, remove item is... Are you sure? I can't see, I don't see the code where you're actually wiring these up. And this'll add a new item, but this one should delete it. And you're saying hitting remove adds an item? What does it add? Let's see. Can you remove this submit? Because you don't actually want to submit the form. It probably won't do anything, but just to make sure it doesn't try to submit something. Because all you want is the on-click handler. You're close. Okay, so here we're actually going to look at the object path. Oh, actually, we put the whole path in there. Thought maybe we just did the UUID. That's fine for now. If we wanted to like remount this though, then all those paths would have to change. And really, I should probably, because you can call mount again, we should probably do that. So I will instead store the UUID. if you were to remount, that would also break the object reference here. So maybe we want a reference to the manager. Instead. Well, log your values. Make sure everything is what you expect it to be. Because I just thought of something. Get element by ID, remove. I don't know if this should change as the value changes. Because it's a pointer to the element in the DOM, so its value should be that value at any point in time. Also, you know, console, so, you know, console log item remove to make sure that that's the key you expect. Console log item just to make sure that that's some kind of object and not, you know, an error. Or something, you know, that maybe undefined or something like that. And as Andy said, make sure your developer console's open. This whole thing here seems really weird, but I was just guessing. ULID, huh? This is pretty cool. Yeah, I would... yeah, I might switch to this at some point, but for now I'm just going to use UUID. I'll keep that open though. Childs, what's up? Yeah?
He fixed it. Did you already pay him?
Huh?
Did you pay him?
Amanda has it. I'll be right back. was a rusty sighting. Just do a really tall Topo Chico. Console is your console. I mean, it should look like this, right? It might have gotten out, popped out or something, but you know, Option Command I is what does it on Mac, so should open it up somewhere, and then console, and you got this. It'll show you everything here. You can even run code here if you wanted to try and debug values in real time. Yeah, if you want it on the flashing the error and disappearing, yeah, that's pretty crazy. I think it's just a warning, though. I don't think that's actually a problem, but yeah. Oh, hidden. That's weird. Yeah, interesting. You can always do console log though, and just output your own. It should output your stuff to it. And you might want to make sure that it works from the log itself. But if that works, then yeah, I don't think it is. Try a different browser. Wait, did I say Object Manager? Object Manager, what's the problem here? It implements the interface. Oh, because I changed the interface. There we go. All right. Have a good evening in Europe. Thanks for stopping by. So we call it an ID. Just to be a little bit consistent. Oops. Otherwise, we'll take the object and we'll export it. I guess we should determine whether it is a function or not, huh? Though now that I think of it, why even have a separate export func and export? Why not just have export determine what it is? I guess let's do that. V. If reflected type is function, then do export func. Otherwise, assume it's an object. So that makes, let's see, what is this now? Oh, there's another. Double definition. There we go. All right, what's this problem? All right, so now we can try just doing export V. Okay, so now we're starting to run into some limitations of our handler, or rather, we parse this into, we have a destination, we get an object path, which is basically taking the method off of the destination, the last part. So it's assuming the last part is always the method, but if we're referring to a function, there's no method, so we'll probably do what Python does and make the method call, and that's how we'll call callbacks or functions via RPC. So I guess I could do that must API, must export handler. In fact, why don't I do that now? I could really put it anywhere, but wait, how does this work? Do I take... two values? Is this how this works? It'll so we could do this. Does that work? I guess so. Cool. I didn't actually know. It doesn't seem, it's not very often that the multiple return values of a function you can just pass directly into the arguments. So I've actually never done that before, but makes sense. All right, so on the people service here, this calls echo. Demo calls echo. Sure it works. Takes only a function. That looks like wrong logic. All right. Handler does not exist for this destination. Echo, really? Oh, demo. Okay. So what, demo echo? Okay, there we go. So that's an example of export. We've exported this object, which has an echo method. Let me see. Those are fine. I'm surprised you're seeing those. I guess they're warnings. I guess I always hide warnings. Source map is a way to help you better debug errors in JavaScript when they happen. So you don't need them. especially for other people's like major JavaScript, it's like they're probably gonna work. You're not gonna worry about debugging them probably. That's not always the case, but so let's create objects. Object manager. We didn't make a constructor or anything. So we don't need to do anything except set up might as well pretend we have a mount path. So this new object manager, make a reference to it here. And then we will it doesn't like that. Objects. I'll not do a root slash. So anyway, the reason we're doing mount instead of handle is because the object manager needs to know the path that you're mounting it to, whereas if you were to just pass it to handle, the path that you're mounting it to is passed to the API, not to the thing that you're, not to the handler thing or whatever. So unless you wanted to enter it twice, but so it bothers me that this is inconsistent, but we'll come back to that if we need to. So we've got this person struct. And we should be able to say create a person. Their name's name, their age can be 30. I guess we can return a string of the path for now, but let's make this be the so I guess we do need to refer to our service here, objects. register this object. Oops. All right, we should be able to use this now. If we're to call make person, actually let's test echo and make sure our argument stuff works. Okay. So make person Jeff. So this is our Jeff object. We should be able to, oh shit, it's gotta keep running. Okay, this won't work. We've got to do, I guess we'll get rid of this. Let's actually grab this and put it in our QC, which is our demo client. All right, so now we just say demo. Run demo. I have to do another. Can you do tabs? New terminal? Interesting. And switch like this. 0. Can I? How do I? Okay, well. Demo echo. Oh, well. I put them on the same path, or the 4242, 4242. Okay. Interesting. Doesn't seem to want to work. Oh, are they doing different protocols? Let me make sure that dial TCP. WebSocket. All right, that's why. We should be able to just change this to WebSocket. All right. Make person Jeff. Connection refused. Okay. Where are we panicking? Oh, we are? This seems silly. I guess it was to figure out where we would panic, or to figure out when we would run into this and then handle it. So I guess that's better than not handling it. I don't know. I mean, I guess we can panic and just, you know, if it's not an EOF, we'll figure out what to do. All right, hello world, that works. Make person, okay. Alright, so this is going to test the handler that we created for our object manager. In theory, we can call any of these methods here. We can call name and get hopefully Jeff. But I took apart the path wrong. I'm gonna have to start splitting this up soon. Because of that. Well, no, this should. I guess I should really show the whole path. What? Why is that the object path? Oh, did I do something stupid up here in parse? Split it. Yeah, what the fuck was I doing? Oh, if, okay. Object path. Really? I guess it's if I recall, cause it's some if you do ranges in your some will make the second argument a length, but it's actually the index of where you want to go. And I remember that I ran into that somewhere else, so that's the problem there. High is exclusive. Okay, let's try it again. Let's make a person. His name is Jeff. What else can we do with it? We can check his age. I'm not 30. That's interesting. I think because it was expecting a string as the response. QC was anyway. Right. So I'm going to change this to, let's see. Okay, so now I have to start over. The name is Jeff. The age is 30. And we can increment the age. Several times. And then get the age. So that is an object. With state and everything. Mounted under objects, under that UUID. So that's the basic of our object manager. Let's try and do something with a callback though. I guess we'll kind of do a contrived example from now. Say we'll say, so here's a callback, and it takes a string. And we'll say objects register this callback. And we'll print it out. What is it not like here? Oh, it's a function. All right. So I think our code is not set up to be able to run this. Yeah, it's confused. Object not registered. But let's see though. Oh, that works. So we just had to give it anything just to get it to export that thing. So this could actually be just like an empty string or even nothing, I think. Which, I don't know how I feel about that for now, but it works. So we have callbacks. We have an object manager. We need to be able to pass a callback into a call. I'm thinking we could create a type called a handle that has a string field handle that points to a path. Because we need some way to point to pass references to these objects now in other calls. And so they have structured arguments, and so we can just create a type that represents an object handle. We'd then have to look it up and stuff, but this is kind of our down here. And it could have like a resolve method where you pass it an object manager and then it gives you the value or some shit. Object handle. Why don't we do that? Explicit, not to be confused with other types that might have path or handle. You just have a lookup thing, object, and it returns a managed object. Managed object could even return an object handle. Struct object. There's the type problem and how this will be used. And if it's an empty interface, then we would have to type assert it. I guess we can play with this API and see how we would do this. So instead of a string, we would return well, an object handle. That's true. So with the reflection stuff, this is where we could do something interesting where instead of saying take a, no, this would be too crazy. Because part of so it's easy to just take a handle and then whatever we want this to do, return a string representing the person object or whatever, but this example is starting to get too contrived. Goldie, okay, what's going on? Chilling. I'm almost to chilling. I sort of got through what I was going to do a little bit faster than I thought, and so now I have to think through what I want next. I want callbacks and I want handles. Let's see. Okay, so instead of doing this, well, let's see, object handle. We'll just make this like return a string. We'll do like, okay, so we didn't implement a lookup thing here, so we'll do that real quick. Trim prefix. Okay. Object handle. Yeah, I kind of like that it has the affordance of see, what would we want to return though? If we want the managed object, I guess that's the easiest. Wait. So object handle, object taking a manager. Returning a managed object. This seems so ridiculous. But in theory, it might feel right when we use it. This is RPC. So we'd be able to say object. It'll take a while. Oh man, Uma Pessoa? Sorry about that. Thanks for following. I don't know if it's gonna dump JavaScript it's still going to be there. Like, you need to use JavaScript to talk to ASM. So like, there's always going to be JavaScript. I think more people are going to use TypeScript, because even without WebASM, they are starting to do that anyway. So I wouldn't say dump JavaScript. I'd say make things more complicated by doing JavaScript and other things. Okay, now I can't use this generic client as much. But that's good, because we can get rid of this. And instead, create a client. Okay, so we know what we're going to do in this case. Let's see the response here. RPC object handle. Okay, so first we're gonna call demo new person Jeff. That's gonna give us back a handle. And we're going to use that to call demo person using our object handle and getting back a string. And then we'll print out that string. Yeah, no APIs yet. That's interesting. I did not expect that. I guess neither did it. Demo 49. So I guess it just doesn't like that it is a ID reference. Register the object. So that should give me the object. I mean, it could be because of this nonsense, but I don't know. Okay. What is the pointer that we're talking about here? Huh. That's interesting. I didn't know that. I'm gonna do it the other way around and see if this gets us anything better. What is not there? Oh, probably the object, right? That's a good question. Oh shit, it's banned Prunny. FTL. My playlist ended. So it is doing recommendations. I'm fine with that for now. Alright, so we'll not do this. But this, I don't know what the problem is. Oh, because the probably the extra slash. Let's see, where's that code that gets rid of the slash? Way up here. That's totally what it was. But if I'm wrong, there we go. Okay, so that's like vaguely interesting. You know, we were able to have these generic object references that we can pass around and return that represent objects on the other side. We can call methods on those objects. I guess doing an example of that would be good. Object path. This is dumb, but anchor age. No. No. Oh, that's interesting. It should have incremented the age again. Oh, it created a new person, that's why. But then, okay, so now a more interesting thing to do. I'll get used to it eventually. I can only take an argument, so type an object handle. So this is, shit. It's actually not so much an object handle as it is a proxy. Once we add proxy objects, that's basically what an object handle is. Yeah. It's kind of like dbus. Yeah, there's a lot of protocols. Basically, I made an abstraction, so it would actually work over TCP, WebSocket, Quick. For fun, it works over SSH. For fun, it works over HTTP2 or a subset of it that does the multiplexing framing layer. So that doesn't matter as much. It just needs a multiplex transport. And so I made a library that has an abstraction over several multiplex transport. Yeah. And because multiplex transports are so very expressive because you can just create arbitrary connections, virtual connections. So every call could be a connection. That simplifies a lot of the bookkeeping you have to do at the RPC layer. So even though this RPC stuff is getting kind of complicated in its API, the actual protocol is very simple. And then around that basic API is more of like referencing remote objects. Yeah. So protocol to me doesn't matter that much. I'd probably end up using Quick just because it's fast and, you know, new. I think it's the protocol of the future. But some cases where WebSocket is helpful, you can't really do Quick over WebSocket. So I had to create QMux, which was extracted from SSH. And with QMux, you can do it over anything. So TCP. So TCP and WebSocket are based on QMux. Anyway, spent a lot of time yak shaving on that stuff, but it's good to have. That's a very powerful general purpose primitive. But yeah, the ultimate goal here, well, is many things, but all of which is built on this RPC thing. So I might want to start getting into the proxy stuff. Yeah, Quick is Google's re-implementation of TCP on top of UDP with security and multiplex streams built in. Basically everything you'd want, plus it's really, really fast. I don't know how, but even with their TLS equivalent, they have basically instantaneous connection setup. Also, because it's UDP, in theory, it's actually a little bit easier to establish peer-to-peer connections with it. So that's kind of a nice benefit from being UDP. Doing the NAT hole punching stuff. Okay, proxy. I should return another caller. It's basically this. How do I want to do this? And that's basically all it is. So then, I guess I'll do this up here. Proxy implements call. And proxy. Oops. Fuck. So this one's easy. This is just p path plus path. A new proxy. And client equals. What? I'm defining paths. You know, paths. The module. No, what is it? OS paths? God damn it. Path. Oh, it's probably path. That's the problem. But I have a thing called path. God damn it. No. No. All right, try that. And then I know I have code down here. I should wrap up. What's the problem here? Client doesn't implement caller. That's true. We're getting there. I mean, it's not that interesting, but I think it's something that we can build on later. This is almost identical in the client implementation, so. So, what would this mean for our object handle? Because that's basically what that is. I say god damn it. I don't feel like I say that very often. It's more like I'm pissed, but I'm not really pissed. Let's see, I guess I should do a recap. How should I set up this recap? What does our demo look like? All right, let's recap. Wrap this up. Music off. All right, so recapping what we did today. Today we were doing part 2 of this object manager because previously, last time we worked on the object manager, we didn't actually get to the object manager. We made some export functions. Because normally if you want to create a function that's exposed over this RPC, it's got to implement this handler API, take a responder and a call, very similar to the HTTP semantics. But normally you'd want, you know, real functions or real methods, you know, things that look more like common functions, common methods to be exposed. So we created some export stuff, and that's basically what we spent all the time on last time. Coming back to it, I noticed we had 2 functions. We had a public export func and an export. Export was originally just to take any object and go over its methods and then export all of those so that they all have handlers. I don't know why I needed 2, so I just consolidated them. So now export can take functions or objects. If it's an object with methods, it exports the methods. If it's a function, it'll export just that function. Export returns a handler, or rather an error in a handler, which today, I realized looking at another API that that's kind of what the must is often used for. I'd seen must used a lot, but I didn't quite wrap my head around, like I just must not have noticed the signature. I'm pretty sure the common pattern for must is to translate something that returns a value and an error into just the value, and saying if there is an error, panic. So just for fun, I put that in here so that we could use it in our demo code. Otherwise, we didn't touch export, but we did get started on an object manager. Object manager is something that we can mount or put or create a handler on a path, which we actually have to do through its API because it needs to know what path you set it up as. So it takes so you call mount, give it an API and a path, and it'll set up itself as a handler on there while setting its internal mount path, because we use that for stuff. So then once you have an object manager, you can register objects, and all this does is create a UUID for it, and puts it in a map, and it actually returns a wrapper called managed object, which gives you some kind of convenient stuff like dispose, gives you the path, the actual value, and an object handle, which we'll come back to. And so using this, it looks like this. So we're exporting this stateless people service thing that we have defined up here. It's got some methods on it, and it had our test echo thing. It looks like a normal function. Takes a string, returns a string. We pass in our object manager that we created here, so that when we create objects in here, like for example a new person, which we take a name and we create a person object, which looks like this, has a name and an age. So we just hard code an age of 30 and take the name you passed in, create an instance of that object, and then we register it with our object manager, and then we return the handle. And so the handle, all that is a type that wraps object path. And so the object manager knows what path it was mounted at. So it's basically that path plus the UUID. And so as a return value, you get the object path, which you can then use for various things, like referencing it. So here's an example client program. And we called new person, Jeff, and we get back the object handle. Then we use the object handle to call a method on that object that was instantiated, is now managed by our manager. And so it's nothing fancy yet. So it's just, we say object path and add a method to it. Increment age doesn't actually take anything or return anything. It increases the age by 1. And remember, when we create them, we start at 30. So this will set it to 31. And then if you saw, there is a person function that's exported that takes an object handle. And so we're just kind of testing what it was like to work with object handles. This returns a string that basically does a, printf of the object value, so we can see its name and age and stuff like that. So running this looks like this. So we said new person, it created that person object, created a UUID, put at this path. We got back a handle that references that path. We use that path to then call a method on it, specifically age increment. And then we called person with the object handle, which basically gives us a string showing us the state of that object, and you can see the age is 31. So we also, I guess in our code here, we did a test where we registered a callback, or rather, in this case, just a function. So just making sure that we can register functions in our object manager. And that's kind of important because that's ultimately one of the main things that I want to use the object manager for, is being able to create APIs that take callbacks. And so you need to be able to, on your side, create the callback, register it, and pass it to the other side somehow. And then that side's going to turn it into something that it can call, which will then call back and give you the result of calling that function. So we're basically there. The thing that I'm missing is this handle object thing that I'm doing here overlaps a little bit with this idea of a proxy or a proxy object. And so this is also borrowed from the API for dbus, where the caller API, so a client is a caller where you can call a path and that you could also get a proxy, and all a proxy is something, it's like a shortcut to a path. So you could say, give me a proxy to this path, and so maybe that path is an object. So then that would give you back something that has a call where you could just say the method name. And so it's just kind of a little convenience system. All it does is wrap a client and a path. The call calls the client with the path joined with the path you want. So simple stuff. You can then further proxy on that if you wanted to, because it is a caller. And so somehow I have to ideally make that work. So maybe the instead of having an object handle, it's an object proxy, and so this is the type that's used by proxy. So when you get an object handle, it's immediately a proxy that you can use. I don't know yet. So that's the part where we're gonna have to kind of start playing around with it, but we're getting there. And that's all just kind of like API niceties. There's enough here, I think, to actually do an API that takes callbacks and uses callbacks. Oh, I guess the one thing that I started running into is because we started to prototype this idea of, okay, let's try doing a callback. So here's a new method on our people service. This is a contrived example, and it doesn't make sense. We have echo on there, new person. Now we have schedule. Schedule takes arguments of an interval and then an object handle to a function or a callback. And so this is basically like set interval in JavaScript. The idea is it'll start a Go routine and start calling that callback over RPC every interval seconds. And I would not be able to write that because when using export, you don't get any reference to the original like responder and call data. And so what a lot of systems do that do this kind of reflection for RPC is they will check to see if you take if it expects a QRPC responder or a QRPC call pointer, and it doesn't really matter where they are, but as long as they're there, it will populate them. So that allows you to create methods that mostly feel like normal methods or functions, but still have access to the underlying RPC API. So that is probably what I need to do next in order to get this example going. So that's progress. We have an object manager basically, and that's it. All right. See everybody. Tomorrow I'll be working on the game all day and doing more of this Thursday. Goodbye, everybody. Goodbye, Gold Buick. Goodbye, whoever's still around. Crimson, good luck. Keep trying. There's a Discord. Crimson, if you're still around, there is a Discord on the channel. So if you want to continue to get help, join the Discord, and we'll be in there. Working from home tomorrow. Sweet. Me too. All right. Bye.